rendering. Surface rendering, the image is made with small triangles, and this gives this aspect of the image. I've been drawing the nerve. I look at this by transparency. I go around. It's almost the same view as the volume rendering. I see the tooth, and I have been making a mask, a 3D image of the tooth and a 3D image of the bone itself. I remove the bone, and then I see the tooth itself. I see the nerve. I see where the nerve is going along the roots, and then I can make a decision. So you see that it's important to use the right tools to make the right decision. In this case, the decision was to open a path, open the bone, glue some brackets over the tooth, and make an orthodontic treatment to pull this tooth up to the crest of the occlusion surface as the adjacent teeth. So this is what we did. We did that safely because we've been able to use the good tools to make the decision. Now I would like to open to you a new word. This is the word of digital acquisition units. There are several here. You will see them, and digital impression system. This technology allows including these digital impression systems inside the program, which is called Uniguide. There are the iTero from Cadent, the Trios from TreeShape, the 3M SP from Lava. I am using the Trios. I don't have the last generation, but let me show you how it works. This is an image from Trios. This is the last generation. You have a captor, and you go along over the surface of the teeth and over the gums, and this will capture the 3D image of the teeth and of the gums. This is used to fabricate, to replace the impression that we are taking with our alginate impression or whatever impression material you want to use, and this is digital. If something is wrong, you can just erase what is wrong and go back and make a better impression. So this is fast. It takes around 2 minutes to take a full jaw. You can also take the occlusion, and this procedure will become the procedure, the standard of procedure in the future. So it's time to jump because we have this available today. This was in the scope of researchers since a long time, but today it's simple to use and it's available. I have been starting using that today. So let's talk about the STL file. You have to know a new word, you have to know new technologies. STL files means stereolithographic. It's a file format for CAD/CAM software, and this was created by a company which is called 3D Systems. The STL is also known as a standard tessellation language. Tessellation is filling the surface with small things which are next one to the other. You cover all the surface like this. In this case, we are talking about triangles, and all the small triangles are showing a volume. This is what we use when we use the STL format. The other format is called the DICOM format, and this is a series of slices that you get from the CT scan. So when we are in uTreat, we can work with all these different formats, and that's important for you because you will know that you will be able to import that from different sources. And then we go to uPlan. uPlan, we are going to plan implants. The planning can be done with image treatment or without image treatment. This means that you can plan an implant in a volume rendering if you wish. It's open to all implant systems. It's very easy to use. I'm going to show that to you. This is the program showing how it looks like with all the tools on one side and all the elements on the other side. So we can plan implant, we can plan retention orthodontics implant, we can plan implant in a recent extraction site, in bone, in a sinus lift, in all whatever you want to do, you can plan it. So let me show you now how it's working to plan an implant. You go to the implant number 46, and then by default you have all the history of the implants that you've been choosing. And on the other side, you see the implant rotating. With one click, you can place your implant and you can rotate the implant, as I show here, from the top. You can rotate the implant from the bottom. You can move around the implant all around the bone, wherever you want to put it, like this. You can change the length of the implant, and when it goes next to the nerve, 2 millimeters, it's becoming red. Red is a warning color for us. So it says to you, you are too short, too close to the nerve. Then you decide either to keep it or not. And also what you can do, you can change the diameter of the implant, and you can change the diameter, and this will change also the shade of the implant. So you go to implant like this, and you exit to U-Design. In U-Design, you are going to be able to design a surgical guide. And this is the question: how can we be independent to make a guide? I want to have my own guides. I don't want to send my plastic cast and my project to someone, and I don't want to work with a monopoly. I want to be independent. So this is what we can do. We have a program to fully design the guide. It's an automatized process as we need, or we can customize it if we need. It's using universal formats, and it allows making the guide fabricated at the dental lab. This is very important. It's not centralized in one country for all the world. You can go to the dental lab, which is an agreed dental lab next to you, to fabricate your guide. What are the guide's flavor? The guides can be laying on the bone. Be careful if you compare the different programs. Some of them do not allow you to work on the bone. And in many cases, you need to work on the bone. Why? Because you need to change the bone. You need to trim the bone. You need to add something on the bone. You need to remove teeth. So your guide will be a bone-supported guide. The guide can be laying on the teeth and on the mucosa. For this, we need to have a strong support, and this will be a support done over a good image coming from a digital camera or plastic cast today if you don't have this. And the guide can be guided and supported on the mucosa for full cases, so you will not have to elevate a flap. You can work on the mucosa. These are some design of guides that we can build up with the holes and the support. And then we are going to use the guide to place the implant. So U-Design can export a STL file, and this STL file can be used by stereolithography to build up a surgical guide. This means building up the guide layer by layer, or can be used in a CAD/CAM machine. Whatever you want to use, you can use it based on an STL file. Uniguide has agreed a certain number of production centers to allow you to be sure that you are going to get the guide with the good CE and European standards of quality. So this agreed production center must be equipped with the adequate hardware, the good printers, follow the adequate processes, use biocompatible material, USP Class 6, and respects the biocompatible cleaning procedure